This video is presented to you by www.testprepadda.com. Dear students, in this session of trigonometry, we will learn about multiple and submultiple angles. First of all, what are multiple and submultiple angles? Uh, if I take, if alpha is an angle, if alpha is an angle, then if I write 2 alpha, 3 alpha, 4 alpha, etc., these are called multiple angles. Multiple angles. Okay. Now, if I take alpha by 2, alpha by 3, alpha by 4, etc., then they are called, these angles are called submultiple angles. Okay. In general, what can we say? In general, if I write n alpha is a multiple angle of alpha, while alpha by n is a submultiple angle of alpha. Got it? Where n belongs to a natural number. N belongs to natural numbers. Now, this way we define multiples and submultiple angles. We are aware of sine, cosine, tangent of alpha. Now we will try to find sine 2 alpha, cos 2 alpha, tan 2 alpha. Okay, so sine alpha we know. We will try to find sine 2 alpha. If I write sine 2 alpha, how to find this? In the previous session, we have learnt about sine A plus B. So if I write this sine 2 alpha as sine alpha plus alpha, then we can use that formula. And what is that formula? Sine A plus B is sine A cos B plus cos A sine B. So here if I use that formula, it will become sine alpha, that is sine A, cos alpha, that is cos B, plus cos A, that is cos alpha, sine B, that is sine alpha. Fortunately, both are same. So it becomes what? 2 sine alpha cos alpha. So a very interesting identity we got here. Sine 2 alpha is equal to 2 sine alpha into cos alpha. Now, if we divide and multiply cos alpha here, that means if I write in this manner, 2 sin alpha cos alpha into cos alpha upon cos alpha. So it will be what? 2, look at this part. Sin alpha upon cos alpha can be written what? Tan alpha. And cos alpha into cos alpha will become what? Cos square alpha, which can be written as 1 upon sec square alpha. I repeat, sin alpha upon cos alpha is written as tan alpha, and cos alpha into cos alpha will become cos square alpha, which is written as 1 upon sec square alpha. And we know one basic identity that relates sec alpha with tan alpha, that is sec square alpha can be written as 1 plus tan square alpha. Okay, so we got another interesting identity. Sin alpha is equal to 2 tan alpha upon 1 plus tan square alpha. We got sin 2 alpha here as 2 sin alpha cos alpha, and here we got sin 2 alpha as 2 tan alpha upon 1 plus tan square alpha. Okay, now if I replace 2 alpha with alpha, replace 2 alpha with alpha, so what will happen in that case? Sin 2 alpha will be written as alpha equal to, go and check the first identity which we derived here, 2 sin alpha into cos alpha. So it becomes what? 2 sin alpha by 2 into cos alpha by 2. Okay, now in the second one, if I put that, replace 2 alpha with alpha, so sin alpha will be written as 2 tan alpha by 2 upon 1 plus tan square alpha by 2. Got it? Now if you want, you can generalize it. You can generalize it for n alpha. So if I replace 2 alpha with n alpha, then sin n alpha will become 2 sin n alpha by 2 cos n alpha by 2. And here also in the second case I can write 2 tan n alpha by 2 upon 1 plus tan square 1 plus tan square n alpha by 2. Okay, now this is about the sine. Now we will try to find cos 2 alpha. Cos 2 alpha in the similar manner as we did for sin 2 alpha. Here also we will write in the same manner. Cos 2 alpha. Recall what we did for sine alpha. We wrote there sine 2 alpha as sine alpha plus alpha. Here what will you do? Here we will write cos alpha plus alpha. Now recall formula cos A plus B. The formula is cos A cos B minus sin A sin B. Substitute there. It will become cos alpha into cos alpha minus sin alpha into sin alpha, and as a result it becomes cos square alpha minus sin square alpha. A very interesting identity. Cos 2 alpha is coming what? Cos 2 alpha is coming cos square alpha minus sin square alpha. Okay. Now, as we know, uh, cos square alpha plus sin square alpha is 1. So, I can replace cos square alpha with 1 minus sin square alpha, right? So if this is the case, what will be cos 2 alpha value? It will become 1 minus sin square alpha minus sin square alpha, and that comes 1 minus 2 sin square alpha. So another interesting identity we got. Okay. Similarly, if I write sin square alpha is equal to 1 minus cos square alpha, and if I substitute cos 2 alpha will be obtained as 1 sorry, cos square alpha minus 1, and minus minus will become plus cos square alpha. So what is the result at the end? 2 cos square alpha minus 1. Is this clear? Now, in this only, here only, if I divide with cos square alpha, if I divide with cos square alpha, or you take cos square alpha common, so what will happen in that case? It will become equal to this cos square alpha. Inside the bracket I will write 1 minus sin square alpha upon cos square alpha. So what is this sin square alpha upon cos square alpha? Tan square alpha. So it becomes 1 minus tan square alpha, and cos square alpha can be written as 1 upon sec square alpha. So it becomes 1 minus tan square alpha upon sec square alpha, which will be written at the end as 1 minus tan square alpha upon sec square alpha is what? 1 plus tan square alpha. Another interesting identity for cos 2 alpha. Okay, very interesting here identity. Now if you try to find sin alpha from here, it will be what? 1 minus cos 2 alpha, 1 minus cos 2 alpha upon 2. and at the same time you have to take the square root of this, and it should be plus minus, because sine square alpha is 1 minus cos 2 alpha by 2. So if you take the square root, you have to write plus minus. Similarly, from here you can get cos alpha. What will be that? Plus minus root. Here it will become 1 plus cos 2 alpha by 2. Okay. Now we know sine 2 alpha. We know cos 2 alpha. What can we find now? Tan 2 alpha. So here now we will try to find tan 2 alpha, and that tan 2 alpha will be written as sine 2 alpha upon cos 2 alpha. Now substitute the values here. Sine 2 alpha is what? 2 sine alpha cos alpha upon cos 2 alpha. What can we write? Cos square alpha minus sine square alpha. Now divide with cos square alpha. If I divide this with cos square alpha, then in the numerator, what do we get? Cos square alpha. 1 cos alpha will get cancelled. At the end, it will be 2 sin alpha upon cos alpha upon what will you write here? Cos square alpha you have divided, so it becomes 1 minus sin square alpha upon cos square alpha will become tan square alpha. So the result will be what? 2 tan alpha upon 1 minus tan square alpha, and this we got. Okay, this you can get with the help of the formula which we have learnt earlier, tan A plus B. Tan A plus B, and that is tan A plus tan B upon 1 minus tan A tan B. So from there it becomes 2 tan alpha upon 1 minus tan square alpha. Dear students, please note that here the alpha should not be equal to 2n plus 1 pi by 4. Okay, at these angles tan 2 alpha will not be defined. Okay, now cot 2 theta can be, or cot 2 alpha, so cot 2 alpha will be actually written as 1 upon tan 2 alpha. Now if I write, it becomes 1 minus tan square alpha upon 2 tan alpha, and now you write tan alpha as 1 upon cot alpha. So it becomes 1 minus 1 upon cot square alpha upon 2 into 1 upon cot alpha, which finally written as cot square alpha minus 1 upon 2 cot alpha. But dear students, here also the condition is there. Okay, alpha should not be equal to n pi by 2. Alpha should not be equal to n pi by 2 here. Okay, this way we get cot 2 alpha. Now I will express sin alpha by 2 and cos alpha by 2 in terms of sin alpha. Okay, so I will write here expression of sin alpha by 2 and cos alpha by 2 in terms of sin alpha. Now, we have already written sin alpha as 2 sin alpha by 2 into cos alpha by 2. Okay, so use this formula, algebraic formula a plus b whole square is equal to a square plus b square plus 2a into b. If I write sin alpha by 2 in place of a and cos alpha by 2 in place of b, I will get here sin alpha by 2 plus cos alpha by 2 square is equal to, here sin square alpha by 2 plus cos square alpha by 2 will become 1, the basic identity 1, plus 2 sin alpha by 2 cos alpha by 2 can be written as what? Sin alpha. So at the end it comes 1 plus sin alpha. Similarly I can write sin alpha by 2 minus cos alpha by 2 square is equal to 1 minus sin alpha. Okay, now with the help of these two, I can write sin alpha by 2 plus cos alpha by 2 is equal to plus minus root 1 plus sin alpha. Okay, and consider this as relation 1. Relation 1. And sin alpha by 2 minus cos alpha by 2 can be written as plus minus root 1 minus sin alpha. Consider this as relation 2. Relation 1, relation 2. Okay. Now, the values of relation 1 and relation 2 will be positive or negative. To understand that, what I will take sin alpha by 2 plus cos alpha by 2. Uh, I can write this as root 2 sin alpha by 2 plus pi by 4. How? It's simple. If I multiply and divide with root 2 here, if I multiply and divide with root 2 here, it will be root 2. Inside the bracket, I'll write 1 by root 2 sine alpha by 2 plus 1 by root 2 cos alpha by root. And 1 by root 2 is the value of sine 45 degree and cos 45 degree. So I'll write here first as cos 45 and here sin 45. Cos pi by 4, sin pi by 4. So what will be happen? Sin A cos B plus cos A sin B can be written as sin A plus B. Got it? So root 2 sin alpha by 2 plus pi by 4. Now this expression will be positive if this sine alpha by 2 plus pi by 4 is positive. And recall the graph 0 to pi and then pi to 2 pi. So alpha by 2 plus pi by 4, if this value is between pi and 0, then this expression will be positive, or you say relation 1 will be positive. If I find in terms of alpha, then it will be alpha by 2 less than or equal to 3 pi by 4, and here it will be minus pi by 4. Here the expression will come positive. I am talking about relation 1 only. Now, for negative, what will you say? The value will lie between pi and 2 pi. Which value? Alpha by 2 plus pi by 4. Okay, so what can we write for alpha by 2? Alpha by 2 will be in between 7 pi by 4 and 3 pi by 4. Here the expression R1 will be negative. Got the idea? Now, we will understand this diagrammatically. Consider this as point A, B, C, D. Okay. The expression sin alpha by 2 plus cos alpha by 2 will be positive when the alpha by 2 lies between minus pi by 4 to 3 pi by 4. So what I do, I will select that pi by 4 angle in a negative direction. So this I can write as minus pi by 4, which is actually in the anti-clockwise direction. If I go, it will be 7 pi by 4, and this side, this is 3 pi by 4. Okay, now minus pi by 4 to 3 by 4, it is positive. So this side it is positive. This side it is positive. And this side, if I talk about, this side it is negative. Got the idea? Similarly, I will talk about the sine of sine alpha by 2 minus cos alpha by 2. Okay, so sine alpha by 2 minus cos alpha by 2 in similar manner can be written as root 2 sine alpha by 2 minus pi by 4. So what will you say? This expression will be positive if alpha by 2 minus pi by 4. This angle lies between 0 to pi. And if this lies between 0 to pi, the alpha by 2 will lie between pi by 4 and 5 pi by 4. Similarly, the expression will be negative when this angle lies between pi to 2 pi, and when alpha by 2 minus pi by 4 lies between pi to 2 pi, the alpha by 2 angle will lie between 9 pi by 4 and 5 pi by 4. 5 pi by 4, and this 9 pi by 4 is actually pi by 4. It is 2 pi plus pi by 4, right? 2 pi plus pi by 4, nothing but pi by 4. Okay, so diagrammatically if I try to explain, I'll take a circle again. This is point A, this is point B, this is point C, this is point D. In this diagram, this is pi by 4. This is 5 pi by 4. So this side it is negative. And if I say this side, it is positive. Got the idea? So this side negative, this side positive. Now I will explain in a if I point this consider this as point P, this as point Q, and in the second diagram this point as R S. Okay, so diagrammatically if I try to explain P and Q, okay, so if I select this range, this is minus pi by 4 to plus pi by 4. Here the relation 1 is positive, relation 2 is negative. You can see in the diagram here negative relation 2, while relation 1 here it is positive. You can see here it is positive. Now in the second one, in this range, In this range, what is the angle? Pi by 4 to 3 pi by 4. 3 pi by 4. Here, the relation 1 is positive, relation 2 is also positive. Now the third portion. Here it is 3 pi by 4 to, everywhere we have to take alpha by 2 alpha. 3 pi by 4 to 5 pi by 4. Here the relation 1 is negative while relation 2 is positive. You can see relation 2 is positive while relation 1 here it is negative. Now the last portion here, the angle 5 pi by 4 to 7 pi by 4. Here the relation 1 is negative, relation 2 is also negative. Relation 1 negative, relation 2 negative, both negative. So diagrammatically we can explain this easily. So here we learnt about the expression of sin alpha by 2 and cos alpha by 2 in terms of sin alpha. So we will take here positive value or negative value will be decided by the angles alpha by 2. One more point. If I add this, the cos alpha by 2 will get cancelled and this way I can get sin alpha by 2. Okay. Now if I subtract then sin alpha by 2 will get cancelled and this way I can find cos alpha by 2. Okay. Now in this session we had discussed many things. We started with the multiple angles and submultiple angles. In the next session, we will try to find the uh, values of geometrical ratios of some important angles. Important angles like 18 degree, like 36 degree. Okay, thank you. This video is presented to you by www.testprepadda.com. Testprepadda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.